So particle formation and removal mechanisms, the formation mechanisms are nucleation, condensation, coagulation, and mechanical formation. Nucleation is when a gas becomes a particle, which we call gas-to-particle transformation. Condensation is when a gas attaches to a particle. Coagulation is when two particles attach to each other. Once they attach, it's very hard to detach. And the only way they can detach is in the lungs, where the lung surfactants might dissolve them. So they make the fine particles ultra fine that they can dissolve and they can get into the through the epithelium and to the bloodstream. And mechanical formation is erosion, grinding material, and usually mechanical formation produces coarse particles, whereas nucleation, condensation, they produce mostly fine particles. Removal, coagulation, if two particles A and B get together to make A, B, it's a removal for A and B and a formation for AB. Diffusion, when the the gases, we have Brownian diffusion that they collide with the particles, the gas molecules with the particles, and these collisions make the particles doing zigzagging. And the smaller the particles, the bigger the zigzagging they do, the faster, and the bigger, the less. And when the particle approaches the surface and zigzags, attaches to the surface, and this is the reason we see dust on the walls or on television, sometimes, on the screen, on your computer screens, etc. And that's basically by diffusion. With the position, when it rains, the particles can be uh, scavenged by the clouds, and then when it rains, they precipitate. Or when it rains, the particles which are below the cloud, they are washed out, and usually after the rain, the concentration of particles in the atmosphere is very low. And sedimentation is basically particles, they settle because of the gravity. For particles above 2 microns, um, gravitational forces are important, and sedimentation is a main mechanism, whereas for small particles, sedimentation is not as efficient because they're too light. And I had the figures here, particle formation by condensation, which we call the condensation growth. Like, we talk about COVID um, um, the the other day, and water can go inside particles and grows, and that would be condensation, right? So the or particle water can go out, like in the case of the COVID particles, dry out, which is the opposite of condensation. So in general, water can go in and out. When it goes in, it grows the particles. When it goes out, shrinks the particles. Okay. Um, and this is the coagulation, particles, very small, ultrafine particles being together. Usually these like combustion particles are like this, necklaces of carbon ultrafine particles.